Today we are going to talk about hyperbolas. They are the most complicated out of the conic sections. Okay, I don't want to scare you, I just want you to be prepared. Okay, graphing them is a little more intricate than the other two that we've seen. So first of all, we always start out with our geometric definition. Okay, a hyperbola is a set of points in the plane, the difference of whose distance is from 2 points is a positive constant. Okay, so this is very similar to the geometric difference of an ellipse. Remember when we talked about an ellipse, we had a point and we added up the distances to the foci and they were the same. This time we're going to subtract the distances from the foci to the point and it's going to be the same. So you'll see in my picture, here is a point. When I talk about the distance to each focus, I take the difference, it's going to be the same if I look at a different point and look at the difference between the two. Okay? Now, let's just talk about this picture for a little bit. When you first saw a hyperbola, you thought it looked kind of like two parabolas going in opposite directions, right? Okay? What? Okay. What we're going to have a center, like we do in our others, okay? We're going to have two vertex points where our hyperbola is open from, okay? Just like in a parabola, we're going to have a focus inside of each curve. And then something that's unique about the hyperbola, we are going to have asymptotes that tell us how to make our shape. Okay. You'll also see here I have a note about the transverse axis. It's the line that's going through the foci, vertices, and center. So it's this line right here. Since our transverse is horizontal, and that's what way our curves are opening, this is a horizontal hyperbola. Okay? So wherever, whatever line our vertices and foci lie on is the way that our hyperbola is going to open. That's how we describe it. It is horizontal. Okay? Any questions about this picture? Obviously, I'll tell you how to find all these things, but any questions about the picture? What we're going to have to graph is the center. We're going to have to graph the vertex points. We'll need to graph these points right here so we can get our asymptotes. We'll need our foci, and then with the asymptotes, we'll know how to draw our curve. Okay? So let's talk about the standard form. Okay? When we talked about a parabola, we can recognize it how? In algebraic form. Only one variable was squared, either the x or the y. How about an ellipse? Both are squared and if they're on the same side, they're both positive, right? They're added together. Both are positive. Okay? When we talk about a hyperbola, we're going to have two squared terms. However, we are going to have subtraction. No. No. Okay, Here again, we have a squared and b squared. But unlike the ellipse, a squared is just always going to be with a positive term. A does not have to be bigger than B, all right? It's just always with a positive term. Okay? Our center is still going to be at HK. Our foci are still C away from that center. Our vertices are still A away from the center. And I want you to just recognize that we're going to have asymptotes, but please do not write the equations like this. I'm going to show you how to find the equation based on our graph. Okay? So just write down that we're going to have asymptotes, but I will tell you using the graph how to find it. Okay. So one thing I'll point out, you'll see that the difference between our distances is 2a, which means a squared plus b squared is c squared. Okay, for an ellipse, we have a squared minus b squared. For a hyperbola, we're going to have a squared plus b squared. Okay. So, this is the process you're going to do to actually graph these, okay? The first thing you need is your center. So you will plot your center. Okay? The next thing you need are your vertex points. Okay? They are always going to be A away. And since A is with X, we know we move horizontally. So we're going to move horizontally A and horizontally A. Now what we're going to do to actually get our asymptote so we know our curve, okay, we're going to kind of treat this like we would an ellipse, and we're going to use B. B is associated with Y, so I'm going to move B vertically from my center. Okay? Yes?
So does A go with always with X or always with the positive?
Always with the positive. Since this is horizontal, it's with the X. Because the X term is positive. Yes, which we'll look at. Okay? Now, do you see how these points remind you of an ellipse? Instead of an ellipse, we're going to draw a rectangle. Very lightly, very, very lightly. And then the diagonals are our asymptotes. Okay. So then from there we can go ahead and write the equations which we'll talk about. Okay. Then our foci are C away. So once you find C, using a squared plus b squared equals c squared, then you can plot your foci inside of your curves C away from the center. Okay? Your curves will start at the vertex, and you're just going to, you know that an asymptote means your curve has to approach it, so that's how you're going to draw your curve. Questions? Let's talk about it again, but now with a vertical hyperbola. A vertical hyperbola, notice the difference. Now our y squared term is positive. Okay, when y is positive, y we associate with vertical movement, so we have a vertical hyperbola. Okay. Remember, the a squared always goes with the positive term. Okay, nobody has a question? Okay. Our center is still at HK. Please be careful. We had an issue on the quiz. Even though the y comes first, that does not mean it's the first coordinate in your vertex. The x, then the y. Okay? Your foci are still going to be COA from the center, but this time we're moving which way? Vertically from the center. Our vertices are still going to be AOA from the center, this time vertically. And we're still going to have our asymptotes. So here's a picture of a vertical hyperbola where we have our center. Okay. Here we go, vertically A and horizontally B, because that's where A and B are associated with. We draw our rectangle and draw our asymptotes. We have our vertices plotted so you can get the shape. And then our foci are COA. Yes?
Can you make us multiplication of the asymptote?
Yes. Okay? So let me remind you about something called point slope form. That's what we're going to use. What is point slope form? Y minus your y value equals slope times x minus your x value. What we're going to do, we're going to use our center as the point, and we can easily figure out the slope based on what A and B are. So instead of doing a bunch of algebra to solve for the y-intercept, I'm going to just have you put it in slope-intercept form, because you have your point, the center, you have your slope, just write it in point slope form and leave it. Okay? In calculus, you're going to use point slope form a lot, and they don't care if you rearrange it to slope-intercept form. So that's what we're going to do. Okay? I'm giving you kind of an easy way out of finding the formula. I would use your center, because you know what your center is, no matter what. Well, this is 1 point. You have to keep y and x, so it's an equation. Okay? Alright, so we're going to do 2 examples. One's going to be fairly simple. The other one we're going to have to do a little bit more work. Okay? First of all, how do we know it's a hyperbola? Okay, we have 2 squared terms, but their subtraction was one of the terms. Okay. What kind of hyperbola do we have? We have a horizontal. We know that because the x squared is the positive term. Okay? So, first of all, where's our center? Oh, that's nice. What is our A value? Good. The A value goes with the positive term. What's our B value? 5. Okay. So to get our vertex points, we need to move, in this case, horizontally, because we have a horizontal hyperbola. And whatever's associated, whatever A is, whatever's associated with that positive term, that's how far we move. So our vertices, we're going to move 3 horizontally from each side. Okay. Now what I'm going to do, I'm going to sketch in B and our rectangle very lightly. So my lightly is going to be my green color. Okay. So since B is 5, I'm going to go in this case vertically. And I'm going to make a very light rectangle. Okay. Our asymptotes, remember asymptotes are dotted lines, right? And we're going to draw our asymptotes through the diagonals. Okay. So we're going to use our center 0, 0. We also need our slope. That's easy. We go up and over 3. Okay, so this asymptote, we have y minus 0 equals our slope 5/3 times x minus 0. What's the slope of the other one? Negative 5/3. It's always going to be negative of whatever the other one is. So y minus 0 equals negative 5/3 times x minus 0. Okay? So what you're going to do, you're going to take your vertex points and you're going to make a curve that approaches them.
So if we need to have any points on our graph?
Nope. Nope, you're going to use the hyperbola. You're going to use the asymptotes to get your shape.
What is the first? Oh, from my.
Okay, but we still need it, don't we? Okay, so we need our C value. C squared is A squared plus B squared. What's A squared plus B squared? So C is the square root of 34. So from our center, we're going to move horizontally. So our foci are 0 plus square root of 34, 0 minus square root of 34. And we say it's the same y value. Now square root of 34, that is almost and there's our hyperbola.
Distance from each.
These foci are important because if I look at a point, okay, the distance from the if I take the distance from each foci, the difference is the same no matter where we are. Just like in ellipse, we had that special property. We didn't use it to help us graph, but they are important to the graph. So we need to take them on. Okay? Other questions? You can write plus or minus. Okay. Paige asked on our asymptotes, can we write one equation with a plus or minus? Yes, that is fine because your slopes are going to be one's positive, one's negative. Okay, let's do a little bit more work.
But
Okay. First of all, how do we know this is a hyperbola? Okay, we have two square terms where one of them is negative.
yay.
Since the x squared is negative, the y squared is positive, we know this is going to be what kind? It's going to be vertical.
Gotcha.
Okay, but what do we need to do?
Complete the square
Why do we need to complete the square?
because non-standard form.
We need to put it in standard form. So to complete the square, from our y squares, we need to factor out
16
16. So we have y squared
plus 4.
plus 4y plus a mystery number. What do we need to factor out from the x's? A -1. So x squared minus 2x plus a mystery number, and we'll move -47 over. Okay? Now be careful, because some of you were not careful on your quiz yesterday. What completes the square here?
4.
4, but we're really adding.
What? Like
64.
Okay? What's our mystery number here?
1.
But we're really adding.
-1.
-1.
-1.
So we have 16 times y plus 2, the quantity squared, minus x minus 1, the quantity squared, equals,
16.
that's convenient,
It is.
because then we divide by 16 because it needs to be equal to 1.
How about that?
And here's our standard form.
Would you always have to make it over 1, like the standard form?
If you put it as y plus 2 squared, that is fine. I just put it over 1 so we can see what a squared is. Okay? Now, be careful. What's our center? 1, -2. Okay? What is A? And what is B?
4.
4. Okay, since this is a vertical hyperbola, we're going to move A vertically, and we will move B horizontally. Oh, let's write our vertices first, though, because those are important. So our vertices are -1, -1, and -1, -3.
Yeah.
So it'd be 1 -1, 1 -1.
Yep, I don't know why I put negative there. Sorry, thank you. Okay, so we moved A vertically because A is associated with Y. We'll move B horizontally since B is associated with X.
Yes.
But we don't have to actually record those points. We're just going to use them to make a
Box.
rectangle. Okay? So, our asymptotes. Okay? First of all, our center is at 1, -2. That's going to be our point for point slope form. The positive slope, what's the slope? Up 1 over 4. So, y minus y, so y minus 2 equals 1/4 times x minus 1. Okay? And then we have a -1/4 as a slope. So you can write this, or you can write them together as a plus or minus 1/4 in one equation. I don't care. Okay? Leave it like this. Don't distribute the 1/4 and subtract over the 2. Leave it in point slope form. That's all I want. Okay? Now, what are we missing? Okay, well, we need our curve. So just approach those asymptotes, but then we're also missing Foci. C squared is a squared plus b squared. What is a squared plus b squared? So c is the square root of 17. So our foci, we're going to move from our center vertically. So 1 and then negative 2 plus or minus the square root of 17. And the square root of 17 is just over from the center. 1, 2, 3, 4. Oh, yeah, we're going from the center. 1, 2, 3, 4. I got that one. Okay. I just miscounted. Thank you. Okay. Okay. Which one was wider, the second one or the first? Let's look. I'll be like the eye doctor. Here's the first one and the second. Which one's wider?
Second.
The second. What do you know about the foci in the second?
Further
away. They're farther away. Okay, the wider they are, the more foci go out.
That's cool. Just on page 7. We don't have an A or B. The A or B is just one. Oh, actually it's not.